So now we're going to be using 4 different determinants to solve this system of equations. The first one comes from the coefficients of x, y, and z here, and that's called determinant D. And so the first row would be a 2, -1, and 3 from these coefficients. The constants we use later. And then 1, 5, -4. And then to evaluate the determinant, I'm going to do the method where you recopy the first 2 columns out here, and then calculate the product of the main diagonals. So 2 times 5 times -1, as well as this diagonal and this diagonal. So that's going to be -10 and -4 and +9. Then we're going to subtract what's called the minor diagonals. So multiply these guys here and here. So that's going to be a -15. 12 times 2 is 24 negative. And then 3 ones is going to make a +1. And then -10 minus 4 and a 9, and then switch the signs, so that's going to be +15 plus 24 and minus a 1 is 33. And there we're already 1/4 done. Now what we're going to do is the same thing, except for this column, which was the 2, 1, and -1, we now replace it with the constants, and that's called the determinant dx. So replace the x's with 17, -19, and -9. And then the y and the z information stays the same. And again, recopy the first 2. Alright, we're ready. So here's the main diagonals. Numbers are going to be a little bit bigger this time. 17 times 5, I think that's 85. So the first one would be a -85. Next there would be -36. And then 9 times 19 is a 171 negative. Next, for the minor diagonals, these guys in green, there's 15 times 9, there's 12 times 17, the 12 times 17 is negative, the 135 was also negative, and then lastly a 19 with 3 negatives. And then change the signs. So 66. Alright, now we do the same thing with the y's. So if you look at this matrix, we're now going to replace this middle column with the constants 17, -19, -9, and that's called dy. So 2, 1, and -1 for the x's, that goes back, and then the y's need to be changed. And the z's are 3, -4, and -1. Alright, ready for the main diagonals? that's going to be 2 times 19 is 38, and there's two negatives, so it's positive 38. Then 17 times 4, I think is 61. No, 68. Good thing I checked. So that's positive 68. And then a negative 27. And then I need my green diagonals. So there's 19 times 3, 57, and two negatives make it positive. And then there's an 8 times 9 is 72, positive. And then there's negative 17. So 38, 68, minus 27, minus 57, minus 72, and plus 17. Negative 33. And just one more to go, dz. So then change the x's and y's back to what they were. 2, 1, negative 1, negative 1, 5, and 3. And now the z's get replaced with 17, negative 19, negative 9. Okay, main diagonals. That's going to be a 10 times 9, so negative 90. And then 3 negatives makes negative 19. And then 17 times 3 is 51, positive. And for the last time on this one, the green diagonals. There's 17 times 5, which is negative 85, and there's a 6 times 19, 114 negative, and then the last one is positive 9. Grand total, then plus 85 and plus 114 and minus 9. 132 positive. And then finally, to get the x, y, and z, well, they're all divided by d, so they're all divided by 33. And then for x, you use dx, so 66 divided by 33. And then y, and then for z, it's 132 divided by 33. And so this is going to be a 2, this will be negative 1, and this will be 132 divided by 33 is a 4. And then what I can do to check the answer is go second matrix, edit the matrix. I actually already typed the information in there, but there it is. And then quit. Go back into matrix, over to math, find the reduced row echelon form. Go back into matrix one last time, and under name say A, and then it'll find the reduced row echelon form and verify that the answers that we should have gotten are 2, negative 1, and 4.